By the end of this lesson, you will be able to look at a situation, decide if it's a permutation or combination, and then decide the number of different possible choices that you could have. All right, so first thing we need to talk about is a new operation in math, and that is what's called factorial. So this says, what does n factorial mean? All right, so the exclamation point means factorial. So n factorial means you're going to multiply a number, then you're going to multiply the next number down, then you're going to multiply the next number below that, and so on until you get to the number 1. So for instance, if I want to do 7 factorial, it means to multiply 7 times 6 times 5 times 4 times 3 times 2 times 1, and when I multiply that, I get 5,040. So 7 factorial equals 5,040 because I multiply 6 times 5 times 4 times 3 times 2 times 1. And if you look, that looks a lot like counting principle that we talked about, where we multiply a bunch of things together. So this is used in probability when we're trying to think of different outcomes. All right, we can use what's called factorial for that. It's also involved in the formula for what's called permutations and combinations. So let's define those. So when I'm making different arrangements, they can be permutations and they can be combinations. So first we're going to talk about what is a permutation. So it's an arrangement or listing in which order or the placement is important. So for example, if I talk about AB, it's different from the choice of BA. So AB and BA are two different choices. A combination is when the order isn't important. So for example, AB and BA are considered the same combination of A and B. So for instance, if I want to figure out if I want to know the different ways I would rank my favorite candy bars, then the order is important because a Payday is better than a Kit Kat. However, if I wanted just to say how many different combinations of candy bars I can have, it doesn't matter because if I get a Payday and then a Kit Kat, it's the same as getting a Kit Kat and then a Payday. So we have formulas to find permutations, and we have a formula to find the combination. So the formula for a permutation, and then we'll use it, and then we'll talk about the formula for a combination, and then we'll use it. So there's two different ways you can write out a permutation and combination. First, you can say like this, or you can write it like this. Okay, and these are both read the same thing, the same way. N things pulled R times. Okay, so the permutation of N things chosen R times. All right, and different books write them in different ways, but the formula is always the same. It's N factorial over N minus R factorial. So let me show you how you would use this formula. So let's say I want to know how many ways the top 5 finishers can be arranged in a 20-person cross-country race. And this is, I know, a permutation. Here's a little keyword from permutation, arranged, and the top 5 finishers. So that order is important when we're talking about how people finish a race. Right? The order is important. So the way we read this is 20 people taken 5 at a time. Or again, you can write it like this: 20 people taken 5 at a time. So I've seen, like I said, I've seen it both ways in textbooks. But this is how it's going to look in the formula. So again, this is N, and this is r. The number of people that you chose or number of things you chose are always should be equal to or less than the total number of things you have. Okay? So, n factorial, so 20 factorial. So again, 20 factorial is 20 times 19 times 18 times 17 times 16 times 15 times 14, all the way down till we get to 1, over 20 minus r, which is the 5 people we're taking at a time, factorial. So let me show you kind of a quick hand way of doing this. So if I have 20 factorial over 15 factorial, and I want to do this kind of quickly without typing in all those things, 20 factorial is 20 times 19 times 18 times 17 times 16 times 15, but I can say times 15 factorial, because 15 factorial would finish that off. So it would be 15, 14, 13, 12, 10, all the way down. And my denominator also has a 15 factorial. So those would cancel. And all I would have to type in the calculator is 20 times 19 times 18 times 17 times 16, which is, I got 1,860,480. All right, so if I want to know how many different ways, we have 20 people in a race, how many different ways could the first 5 people be arranged? It'd be 1,860,480. So that's a lot of choices. And lots of times in probability, it starts getting that big. So like for the probability of winning the lottery is really low because there's a lot of different choices when it comes to picking the numbers for that. Okay, so probability, we start dealing with some big numbers. So again, arrangement matters when it comes to a permutation. For a combination, the order doesn't matter. So let's say I have, like, in a contrast to the problem I just did, if I had a 20-person cross-country team, but I only could take 5 people with me, all right? I can only take 5 people with me. It doesn't matter the order of those 5 people. So if I say, oh, this is my team of 20 runners, but I only can bring 5 of you with me. If I pick Billy first, it's the same as if I pick Billy 5th. But if he comes first in the race, it's not the same as him coming 5th in the race. So when order doesn't matter, that's a combination. And we say it's a combination of n things taken r at a time. You can still write it this way as well, n things taken r at a time. And that formula is n factorial over n minus r factorial times r factorial. So what that does, it ends up making less outcomes, okay, because your bottom number is going to end up being higher than when it would be with a permutation. So, a science class with 42 students, how many 3-person lab teams can be formed? So, I have 42 students, but I'm taking 3 at a time. Again, another way I can write it is 43 students taking 42 students taken 3 at a time. All right, so that would be n is 42, so 42 factorial over 42 minus 3 factorial over 3 factorial. And again, if I want to solve this without typing too much in, let's see, 42 factorial over 42 minus 3 is 39. So I would do 42 times 41 times 40 times 39 factorial. So 39 factorial, again, I'm trying to get those to cancel out. But I still have this 3 times 2 times 1 to deal with. So I get 60,880 when I multiply 42 times 41 times 40 over 6, 3 times 2 times 1, which gives me 11,480 different 3-person lab teams. All right? Now here's the good news for you guys. I have some really good news on the next slide. Desmos does permutations and combinations, so you don't have to put them into the formula. Your biggest problem or biggest issue for this, or the hardest problem, the hardest part of this lesson is choosing if it's a permutation or is it a combination. Once you do that, then you can use Desmos. So first of all, Desmos does factorials. So if I want to do 5 factorial, I just type in 5 exclamation point, and that'll give me the factorial. If I want to do permutations and combinations, these are the previous 2 problems I just did. I'm going to hit functions, statistics, and here is combinations and permutations. So that's where you find them. So if for number 1, we did a permutation, 20 people taking 5 at a time. So I selected the permutation there, parentheses 20, comma 5, and then Desmos gave me the answer we had. And then for combination, again, I'm going to select combination when I go to functions and stats. And then I just type in 42 and 3, and that gave me 11,480. So when you go to do your problems, you luckily don't have to write out all the factorials and all the formulas. But I did want you to at least see that so you knew where those were coming from. All right, so all Desmos is doing those formulas for you. So again, the hardest part of this lesson is deciding if something is a permutation or is it a combination. So remember, permutation, order matters, combination, it doesn't. So I like to look for keywords. So order, arranged. If we're talking about the order of the order some people finish a race. Those sort of things are permutations. If we're just combining things together, then we're talking a combination. So how many ways can you make a sandwich by choosing 4 of 10 ingredients? It doesn't matter what order you put ingredients on the sandwich can be the same, unless you're my dad who thinks mustard, relish, and chili go in a certain order in your hot dog. But we're not talking about my dad. We're talking about any random sandwich. So order doesn't matter, so this is going to be a combination, because if I put lettuce, tomato, pickle, it's the same as pickle, lettuce, tomato. Okay, it's going to taste the same. So this is a combination, because order doesn't matter. All right, and when we go to type this, so this is a combination of 10 ingredients, but we're going to choose 4. When I type this in the calculator, again, I'm going to choose this function. I'm going to type in 10 and 4, and it's going to give me, when I type that into Desmos, 210 different choices when it comes to selecting my sandwiches. Okay, so if I can choose any 4 ingredients, again, order doesn't matter when it comes to a sandwich, I promise you. So that's a combination. So 10 things taken 4 at a time. Number 2. How many ways can 11 photographs be arranged horizontally? So there's that key word, arranged. So since it's an arrangement, then we're talking, this is a permutation. Give me a second. Permutation. All right. So how many different ways can 11 things be arranged? So 11 things, I'm using all 11, so it's 11 photographs taken 11 at a time. So they're not saying how many different ways can 11 photographs be arranged if I choose 3 of them. So it's 11 taken 11 at a time. So when I type that in the calculator, I'm going to choose this function, 11 out of 11, which, by the way, is the same as 11 factorial. So if you're taking permutations and you're using everything in that permutation, it's the same as the factorial. So if I want to say, what's the different ways I can arrange 5 racers? Like if all 5 people are racing, what's the different ways I can arrange those 5 people, 1st, 2nd, 3rd, 4th, and 5th? Then it's just 5 factorial. Okay. Well, that's something you don't really Just a little side information there. All right. So when I type in 11 things, taking 11 at a time, and it's a permutation, then it's going to give me this as my answer. And I would practice putting this in the Desmos, making sure you get the same answer I do. So 39,916,800 different ways I can arrange my 11 photographs on my wall. How many ways can you buy 2 software titles from a choice of 12? So let's say there's 12 softwares on sale. You're going to choose 2 of them. Order doesn't matter. If I choose A, B, it's the same as choosing B and A. So this is a combination because order doesn't matter. All right. So for a combination, this is going to be 12 things taken 2 at a time. All right. So when I type that in the calculator, it's going to be, I'm going to type in, select this, and I'm going to type in 12 and 2, and that's going to give me, so that's 66.
I didn't know that was a sharp edge. So bad.
All right, how many ways can a baseball manager make a 9-player batting order? Order, there's my key word, order. Order matters from a group of 16 players. So that's a permutation because order matters. So I have 9 players, and I'm choosing, sorry, that's a lie. I have 16 players, and I'm choosing 9 at a time. All right, so again, I'm going to type that in as such. All right, so whoops, I'm having 16, 9 at a time, and when I type that, I get, good Lord, this is what it gave me in the calculator. So 4.15347 times 10 to the 9th. So it gave it to me in scientific notation. I don't want scientific notation for this assignment, so I'm going to move the decimal place over 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to need to add 3 zeros. Whoops, I left a number out. I knew that wasn't quite right. Hold on. Should be 1 here. All right, let's try that again. So now I'm going to move it over 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9. So I'm going to add 2 zeros. So it's 4, 1, 5, 1, 3, 4, 7, 2, 0, 0. So 4,151,347,200 different batting orders. If I have 16 players, I'm going to choose 9 at a time. How many ways can 30 students be arranged? There's my keyword, arranged, in a 4-student line. So this is a permutation. It's going to be, let's see, 30 students taken 4 at a time. So this is how I'll type it in the calculator. And that gives me 657,720. And again, I encourage you to type that into the calculator. Make sure you're getting the same answers I'm getting. Okay. So again, the word arrange was in there, so it's a permutation. And then since I know it's a permutation, 30 students taken 4 at a time. How many ways can 3 cookie batches be chosen out of 6 prize-winning batches? So I have 6 different batches to choose from. How many ways can I choose 3? Now they're not saying the order of those 3 matter, so it's a combination. All right, so it's 6 different things. I can choose 3 at a time. All right, so when I type that in, I always want to put an equal sign there. I'm going to type in the combination function, 6, taking 3 at a time, and I get that there's 20 different combinations of that. Okay, so again, permutation order matters, but this is a combination because it doesn't matter the order that I choose the different cookies. Oh, we already did number 6. Number 7. We'll cross this guy out. Oh, we don't need to. Students are chosen in groups of 6 to tour a local business. How many ways can 6 students be selected from 3 classes totaling 53 students? So in those 3 classes, altogether there are 53 students. That's what I assumed in this, not 3 classes of 53. So we're choosing 6 students out of 53. Order doesn't matter because they're just making a team, and that's not the order of the team that matters. So it's a combination. And we have 53 students, and we're choosing 6 of them. So this is how we'll type it into the calculator. All right, and when I type that in, I get 22,957,480 different 6 groups of 6. A local restaurant specializes in simple and tasty meals. How many sandwiches are possible if the restaurant lets you build a sandwich by choosing 4 of 10 ingredients? So that's basically what we did up there. So that's still 4 ingredients taken 10 at a time. And when we did that, we got 210. So that's like example 1. Now, let's say we combine that and there are 6 soups to choose from. How many soup and build a sandwich specials are possible? So this is now the counting principle. I have 6 different soups I can choose from, 210 different sandwiches to choose from. So when I multiply those together, I get 1,260. So I found my combination, and then I said, hey, okay, but we also get a choice of 6 soups. So then I go back to the counting principle. 6 soups times 210 different sandwiches, so 1,260 different build specials that I can choose from. So permutation order matters. Combination order doesn't matter, and you can use the statistics functions to type these in to find them. So now what you're going to do is you're going to do 4, 5, and 6, 4, 5, and 6. Those tell you if it is a permutation or if it is a combination. And then 1 through 6, and then 13 through 17.